Assalamu alaikum wa rahmatullahi wa barakatuh. This is our 8th lecture on aldehyde, ketone and carboxylic acid. We have completed till preparation of aldehyde and ketone. In this lecture, we are going to study preparation of carboxylic acid. There are 6 methods which has been given in your syllabus for the preparation of carboxylic acid. In this lecture, we are going to study 3 methods of preparation of carboxylic acid, that is from nitrile and amide, from acyl chloride and acid anhydride, from ester. First method of preparation of carboxylic acid from nitrile or cyanide and amides. Let us have the general reaction for the same. R C triple bond N. This is your nitrile or cyanide. When it is been hydrolysis, here we are writing H2O in this form HOH. The reaction took place. Here triple bond is being present between carbon and nitrogen. Triple bond will be getting converted into double bond. R C double bond N. Now this H2O will break into HNOH. OH will move towards carbon and H will move towards nitrogen, and we are getting an intermediate compound RCOH double bond NH. This is your imide compound. Now let us do a rearrangement reaction, which will be a reversible reaction. We are writing this intermediate compound in a bracket form. Now this H will move to nitrogen, double bond will move towards carbon and oxygen. So we will obtain R C double bond O, double bond here it will be converted into single bond, NH will be converted into NH2. This is your intermediate compound. It is known as amide. Now here from nitrile we are getting an intermediate compound, that is your amide. This amide will further undergo acid hydrolysis. It will undergo acid hydrolysis HOH in the presence of dilute HCl. So what will happen over here? This NH2 will be removed out with H of water, and you will get NH3, that is your ammonia, as a side product, and the remaining behind OH, it will move towards carbon. R C double bond O OH. So here we have obtained acid from nitrile and amide. Fine. This is the general reaction for the preparation of acid from nitrile and amide. I am repeating the reaction again. Nitrile, when it is being hydrolysis, we are getting an intermediate compound. This intermediate compound that is your amide, will further undergo acid hydrolysis. In the presence of dilute HCl, we are getting acid with ammonia as a side product. Now here remember the ammonia which is being prepared as a side product, NH3. This NH3 will be reacted with dilute HCl. This NH3 will react with dilute HCl and you will get NH4Cl, that is your ammonium chloride. Fine. Let us have some of the example over here. Remember student, from this reaction we are going to prepare both aliphatic and aromatic compound. Let us first have an example of an aliphatic compound. In the place of R, we are supposed to replace aliphatic or aromatic reactant. Now, in the place of R, let us write here CH3, C triple bond N, that is your methyl cyanide. This methyl cyanide will undergo hydrolysis reaction. It will undergo hydrolysis reaction and we are getting CH3, C triple bond will convert it into double bond. Now here HOH will break into H and OH. OH will move towards carbon. H will move toward nitrogen. Here it undergo an rearrangement reaction. That rearrangement reaction will be a reversible. So what will happen over here? OH will move towards nitrogen. Double bond will move towards carbon and oxygen. So it will get converted into CH3, C double bond O and H2. Here this is your amide compound, and what is the name of this compound? This is your acetamide. This is your acetamide. From methyl cyanide we are obtaining acetamide. This acetamide will further undergo acid hydrolysis in the presence of dilute HCl. In the presence of dilute HCl, what will happen over here? CH3, C double bond O of acetamide. NH2 will merge with H and NH3 will be your side product. OH will attack over here and we are obtaining acetic acid. So here student, from methyl cyanide which undergo hydrolysis, we are obtaining an intermediate compound. This intermediate compound will undergo rearrangement reaction and we are obtaining acetamide. This acetamide will further undergo acid hydrolysis and we are obtaining acetic acid plus NH3, that is your ammonia. Next example is of aromatic compound. Let us take here benzene ring, C triple bond N, that is your phenyl cyanide. This is your phenyl or benzyl cyanide. It will undergo hydrolysis reaction. What will happen over here student? HOH will break down into H and OH and H will attack on nitrogen. OH will attack on carbon. Fine. So we are getting benzene ring, C OH, the triple bond will be converted into double bond NH. This is your intermediate compound This intermediate compound will undergo rearrangement reaction and we are getting benzene ring C. What will happen over here? This hydrogen will move toward nitrogen, double bond will move over here. So here we are getting C double bond O. Here it will be getting converted into single bond NH2. This is your amide compound and the name of the compound is benzoamide. This benzoamide will further undergo acid hydrolysis and we are getting compound. This HOH will break down into H and OH. H will move towards ammonia, that is your NH2, and OH will move towards carbon. This amide, you are getting in benzamide. H will move towards amide and OH will move towards carbon. And we are getting the compound benzene ring C double bond O OH with side product NH3, that is your ammonia, and the name of the compound is benzoic acid. So here student, we have obtained an aromatic carboxylic compound from aromatic reactant, that is your phenyl cyanide, which on hydrolysis give an intermediate compound, which on rearrangement give you benzamide. This benzamide will further undergo acid hydrolysis and we are obtaining benzoic acid with ammonia as a side product. The second reaction for the preparation of carboxylic acid is from acyl chloride and acid anhydride. First reaction in this is from acyl chloride. What is your acyl chloride or acid chloride? RC double bond O, OH is your acid. RC double bond OH is present over here, that is your acid. When OH is being replaced by Cl, it is your acyl chloride. This acyl chloride will react with water HOH. I am writing in this form. In the presence of suitable solvent such as pyridine or NaOH, what will happen over here? HCl will be liberated out. It is a very simple reaction. HCl will be liberated out and OH will merge over here and we are obtaining RC double bond O OH plus HCl as a side product. So here from acyl chloride we are obtaining acid in the presence of NaOH or pyridine. Now remember here student, HCl is being produced at the end of the reaction as a side product. So to neutralize HCl we are adding base such as NaOH or pyridine. Now let us have an example. Here we are going to prepare aliphatic as well as aromatic carboxylic compound. First reaction is the preparation of aliphatic carboxylic acid CH3 C double bond O Cl, that is your acetyl fluoride. This acetyl chloride will be reacted with HOH. Your HCl will be liberated out. The reaction proceed in the presence of pyridine or NaOH. What we are going to obtain here student? CH3 C double bond O OH plus HCl as a side product. The name of this compound is acetic acid. Fine. From acetyl chloride, we are obtaining acetic acid. Second method is the preparation of aromatic carboxylic acid. Let us take here benzene ring, C double bond O, Cl. This is your acetone chloride. This is your benzoyl chloride. Benzoyl chloride. This benzoyl chloride, when it is being treated at OH, what will happen over here? HCl will be liberated out. The reaction proceed in the presence of pyridine or NaOH, and you are obtaining benzene ring, C double bond O, OH plus HCl as a side product. So from benzoyl chloride we are obtaining, what is the name of this structure, student? This is your benzene, this is your acid. So this is your benzoic acid. This one is the B part, preparation of acid from acid anhydride. Now let us have the general reaction for it. R C double bond O, R C double bond O. Here OH is there, that is your acid. Here OH is there, that is your acid. So here these two are linked with oxygen. This is your acid anhydride. This is your acid anhydride. This acid anhydride, when it is being treated with HOH, here the bond will break. Here the bond will break. Hydrogen will move towards oxygen, OH will move towards carbon, and we are getting two molecules of RCOOH. Let us have an example. First example is preparation of aliphatic acid from anhydride. Acid anhydride. Let us take here CH3, C double bond O, CH3, C double bond O, O. The name of this compound is acetic anhydride. This acetic anhydride, when it is being treated with water, what will happen over here? The bond will break, and we are obtaining two molecules of CH3COOH, that is your acetic acid. The second example is the preparation of aromatic acid. Here we are taking C6H5, that is your phenyl, C6H5, C double bond O, C double bond O, O. This, the name of this compound is benzoic anhydride. Benzoic anhydride, it is being treated with HOH. We are obtaining two molecules of C6H5COOH, that is your benzoic acid. So here student, we have completed two methods of preparation of carboxylic acid. The third method of preparation of carboxylic acid is from ester by hydrolysis. Here we are undergoing two kinds of hydrolysis. First one is your acid hydrolysis, second one is your alkaline hydrolysis. Let us first have acid hydrolysis. Here the general formula for ester is R C double bond O, O R dash. This is your ester. Now R C double bond O, O, R dash. This ester will undergo hydrolysis in the presence of acid such as dilute H2SO4 or HCl. We are applying heat over here. So what will happen? The bond between this carbon and oxygen will break. The bond between carbon and oxygen will break, and we are obtaining RC double bond O, OH plus ROH. ROH. Fine. So, here student, we have prepared acid and alcohol. We are preparing acid as well as alcohol from ester. Now, remember one thing student, if this reaction is to be reversed, suppose we are going to prepare ester, the reaction is reversed, so we are using concentrated H2SO4, which convert acid back to ester, and that reaction is known as esterification reaction. Here, but student, we are preparing acid from ester where RC double bond O, OH will give you acid and ROH will give you alcohol. Let us have an example for the same. First example, CH3 C double bond O, OC2H5. This is your ethyl acetate. This ethyl acetate will undergo hydrolysis in the presence of dilute H2SO4 or dilute HCl. We are applying heat over here. So what will happen over here? C2H5O will merge with hydrogen. It will merge with hydrogen, and OH will merge with this carbon, and we are obtaining CH3COOH, and the name of this compound is acetic acid plus C2H5OH as a side product. This is your ethyl alcohol. This is the preparation of aliphatic carboxylic acid. Let us have an example of preparation of aromatic carboxylic acid. C6H5C double bond O, OCH3. This is your methyl benzoate. 8th word we are using for ester. The name of this compound is methyl benz for C6H5 benzoate. This will undergo hydrolysis reaction. What will happen? In the presence of dilute H2SO4 or HCl, we are applying heat. So here student, CH3OH will be your side product. OH will merge with carbon, and we are obtaining C6H5C double bond O, OH plus CH3OH, that is your side product. So here we are obtaining student, the name of this compound is benzoic acid plus this is your methyl alcohol. Next method for the preparation of carboxylic acid from ester by alkaline hydrolysis. Here alkaline hydrolysis we can take either NaOH or KOH. Let us have the general reaction. RC double bond O, OR dash, that is your ester. These ester, when it is being treated with NaOH, aqueous solution of NaOH, in place of NaOH we can take KOH. Also we are applying heat. What will happen over here? This R will move with OH. This NaOH will break down into Na plus OH minus. So your Na will move towards oxygen and R will merge with OH. So we are obtaining R C double bond O Na plus R dash OH. This we are getting sodium salt of acid. This is your sodium salt of acid. RC double bond OH is your acid. In place of H, sodium is present. So this is your sodium salt of acid. This sodium salt of acid will undergo acid hydrolysis. It will undergo acid hydrolysis. That is, your acidification will be carried out and you are obtaining R C double bond O OH plus NaOH as your side product. So here student, when ester, when it is treated with NaOH, aqueous solution of NaOH, here it undergo alkaline hydrolysis. We are applying heat. We are getting sodium salt of acid with alcohol as a side product. This sodium salt of acid will undergo acid hydrolysis. That is, your acidification process will be took place over here. We are obtaining RC double bond OH, that is your acid with NaOH as your side product. Let us have an example over here. CH3 C double bond O C2H5. This is your ethyl acetate. This is your ethyl acetate. This ethyl acetate will be treated with NaOH. NaOH, that is your aqueous solution of NaOH. We are applying heat over here. We are obtaining C2H5OH as a side product. C2H5OH as a side product, and it will move toward oxygen, and we are obtaining CH3 C double bond O Na, negative charge on oxygen, positive charge on sodium. So this is your sodium salt of acetic acid. The name of this compound, sodium salt of acetic acid. This sodium salt of acetic acid will further undergo acid hydrolysis, that is your acidification reaction. We are obtaining CH3 C double bond O OH plus NaOH is your side product, so that we are obtaining acetic acid. So here student, we have prepared acetic acid from ethyl acetate. Remember student, this reaction is known as saponification reaction. Why? Because this sodium salt of carboxylic acid are known as soap. This higher fatty acid. Which higher fatty acid? Sodium salt of acid. Sodium salt of acid is your soap. So here we have prepared soap. So the reaction is known as saponification reaction. Saponification reaction. One more thing, these higher fatty acid are C double bond O O N A, negative charge, positive charge. This is your sodium salt of fatty acid. In place of NH, if we take KOH, so we are obtaining R C double bond O O, negative charge, K positive charge. So this two salt which is being prepared, this salt is your hard soap, which is used in washing the clothes. This RC double bond O, OK, this is your soft soap. This is used in bathing. So here, student, we have completed 3 methods of preparation of carboxylic acid. Inshallah, in the next lecture, we are going to study 3 more methods for the preparation of carboxylic acid. Thank you.